The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of 6-digit numbers involving zeros as lower digits. Example, 117,000. Let us set the number 117,000 by leaving 3 columns in the right extreme of the abacus. That is 0 set in the thousands column, 0 to the left of it, 0 to the left of it, 7 to the left of 0, 1 to the left of 7 and 1 to the left of 1. For the purpose of calculation, we can consider the groups in order as 11, 70 and 0, 0 as the 3 groups. Take the first group 11 and consider the perfect squares there. 4 and 9 are the perfect squares in 11. Now consider 9, which is the highest perfect square, and take the square root 3. Set 3 to the immediate left of 1 and subtract 9 from 11 and you are left with 27,000. In the next stage, double the number 3 and set 6 in the extreme left of the abacus. Consider 27 of the 270 and ask how many 6s in 27? You get the answer as 4. In case of small numbers, you need not have to go for an assumed quotient. Therefore, straight away set the number 4 to the right of the first digit of the square root and it becomes 34. Set the number 4 to the right side of 6. Now multiply 4 with 64. That is 4 multiplied with 6, that is 24. That should be subtracted from 27 and the remaining number is 30. Now 4 multiplied by 4, which is 16, and that should be subtracted from 30, which gives the remainder as 14. Now you are left with 1400. Look at the square root now. In the square root section, we have 34. That should be doubled, and therefore the 64 in the left extreme of the abacus will become 68. Now consider 68 and 1400. Look at the first 2 digits of the dividend and the divisor. Ask how many 6s in 14 by saying 2. Set the 2 to the right side of the square root 34 and to the right side of 68. Now multiply 2 with 682 and subtract that from 1400. That is 2 is multiplied with 6, which gives 12. That should be subtracted from 14 and the remainder is 200. Now multiply 2 with 8, which is 16, and therefore subtract 16 from 20 of the dividend. Now you are left with 40. Multiply 2 with 2, which gives 4. That should be subtracted from 40 and you are left with 36. Now you have to go for your decimal part of the square root. Add 1 0 to the dividend, that is 36, and it becomes 360. From here on, you can simply follow the regular division procedures in getting the decimal part of the square root. For getting the divisor, you can double the square root 342, which is 684. As 684 is larger than 360, the first decimal digit of the square root becomes a 0. And at this stage, the square root becomes 342.0. Add 0 to the number 360 and get the second decimal digit of the square root. When we are going to the second decimal digit of the square root, you can round off the divisor and get approximate values. Now, the rounded off number to the divisor is 700, as 700 is closer to 684. Now ask how many 700s in 3600. By saying 5, you place the value to the right side of the existing square root 342.0. Now multiply 5 with 684, that is 3420, and subtract the same from 3600 and you will get 180 as the remainder. Now you add one more 0 to 180 and make it as 1800. Now look at the divisor, which is 684, which is closer to 700. Now ask how many 700s in 1800. There are 2, and therefore take a 2 as the third decimal digit of the square root and subtract 2 multiplied by 684, that is 1368. When you subtract this from 1800, you get the value 432. Now you have to go for correction with the third decimal digit. Let us look at the remainder, which is 432, which is higher than the midpoint 342 of 684, and therefore the decimal part of the square root may be rounded off to 342.053. That means the 2 in the square root becomes 3. Again, we may note that though many numbers and sections are involved in the square root problem, no column is running into the other in the calculation process. When we find that the subsequent columns are filled with beads, the calculation always clears way for the next digit of the number to set in. Therefore, the correct hand position and operation of the beads in the respective columns in the abacus becomes absolutely important.